Today we are talking about what is called the first fundamental theorem of calculus. The first fundamental theorem of calculus. Now, with a name like that, you can pretty well guess that this is a very important theorem as far as the study of calculus is concerned. And it is important because what it does is it ties together indefinite integrals and definite integrals. It ties together indefinite integrals and definite integrals. Before I start the notes formally, what I want to do is talk about the progression of derivatives and integrals. So, let's talk about derivatives first of all, and then integrals over here. The derivative of f of x is called, somebody answer, f prime of x. And the derivative of f prime of x is called f double prime of x, and so on and so on and so on. When it comes to integrals, however, we have to go a little farther than we do with derivatives. The integral of f double prime would be f prime of x plus c, because you're basically going backwards. The derivative of f prime is f double prime, so the integral of f double prime is f prime of x, but you've got to add on the c. The integral of f prime of x would be f of x plus c. Okay? And now finally, we do have to go back one more, and we've never talked about this before. I have forgotten to put the dx on all of these, not being completely formal. That's bad on my part. But what do you call the integral of f of x? Well, we've really never given that a name, but we need to give it a name for what we're going to be talking about now. And what we actually call it is capital F of x. And so basically, capital F is the antiderivative of little f. Capital F is the name we give to the antiderivative of little f. Okay? It's going to come into play in a minute. Okay. Now, indefinite integrals, what do they tell us? Indefinite integrals, such as the integral of f of x, like we just wrote, dx, let's be better on our formality, give us capital F of x plus c. And basically, when we do an indefinite integral, it is given a function, find the antiderivative. That's all. Given a function, find the antiderivative. For definite integrals, what are we doing? We haven't talked about definite integrals yet today. For definite integrals, remember that it looks like a to b of f of x dx, very similar to the other one, and that answer is a number, which is the area under a curve, area under f of x. Now, why would they make two symbols, the indefinite integral and the definite integral, look so similar and seem to have two totally different meanings? Two totally different meanings. Well, actually, there is a connection between the two of them. And that connection, called the first fundamental theorem of calculus, is how we can actually solve an integral that cannot be solved with geometry, and actually it can work for the ones that can be solved with geometry. Here is the way the theorem goes. I'm going to put a star by it to show that this is the theorem exactly. Here's what it says. If f is continuous, sounds familiar, on the closed interval from a to b, if f is continuous on the closed interval from a to b, and capital F is the antiderivative of little f on the same closed interval from a to b, comma. If f is continuous on the closed interval from a to b, and capital F is the antiderivative of little f on the closed interval from a to b, then the following connection is made. And it says the integral from a to b of little f of x dx can be calculated as capital F of b minus capital F of a. The integral from a to b of f of x dx is equal to capital F of b minus capital F of a. So we now have a connection between an antiderivative and a definite integral, which we have never had before. This ties together both the definite and the indefinite integral. Now, I'm going to show you how this works using problems with geometry, because geometry we can do by hand, and then I'm going to show you that the calculus method by using the antiderivative gives you exactly the same answer. So, let's start with an example. We're going to take the integral from 0 to 3 of 5 dx. We're going to do it with geometry, and then we're going to do it with calculus. Let's go ahead and write geometry all the way out. Geometry and calculus. Okay, geometry was what we've been doing the last couple days. We draw the picture. This tells us to go from 0 to 3. The graph of 5, we've done that many, many times. That is a horizontal line at 5 that goes like so. I'm already connected to 0. We need to connect at 3, shade it in, and what do we get for an area? The rectangle is 3 units wide, 5 units tall, and the area is 15 units squared. Okay. Now, let me show you the formal way to write this when you do it without a picture. So what we write is the integral from 0 to 3 of 5 dx equals. Okay? The first thing you've got to do before you go to this step with the capital F of b minus capital F of a is tell me, what is the antiderivative of 5? And the antiderivative of 5 is 5x. But we don't put the c, and I'll talk about that in just a minute. What we do put is the back half of a bracket, and we bring over the 0 and the 3 like so. We don't put the c. Now, the b value, remember, is the upper one, which is 3. So you plug in the 3 for x, so it's going to be 5 times 3 minus 5 times the a value, which is 0. And lo and behold, we get the same answer we just got with geometry, which is 15. All right. I'm going to go to the next piece of paper, and I'm going to talk about why we don't write C down. All right. Why do we not do plus C? Why no, quote, plus C, end quote, question mark? Okay. I'm going to do the exact same problem, and I'm going to go ahead and put the C in there. But I'm going to show you that you really don't need it. We're just saving ourselves some writing when we don't put the plus c. Okay? The antiderivative of 5, like we said, is 5x. Go ahead and put plus c. Go ahead and put it. Then put the 0 to the 3. Okay? Now remember that c is a constant. So when you're plugging in the 3, you don't worry about the c, but you bring it along. So if you plug in the 3, you would get 15 plus c minus, now plug in the 0, 0 plus c. Now what happens to the c's? They will always cancel, because you're going to have a plus c in this problem, and you're going to have minus a plus c in this problem. They will always cancel out, and you'll be left with the answer as it stands. So, why bother writing the c down if you don't need it? So that's the one thing you're going to really have to remember. When you're doing a definite integral, you don't put plus c. You just write the antiderivative. You forget about the plus c. If you happen to write it and you forget, it's not going to hurt anything. It's just more work that you don't have to do. All right, let's do another example. Let's do the integral from 0 to 4 of 2x dx. We're going to do it with geometry and then with calculus. Okay, geometry is not a problem. The reason I do the geometry, to show you that you got the right answer with the calculus. Okay, so first quadrant only, because my limits are positive numbers. We write the 0, we write the 4. This graph, 2x. Think about what it is. Is it a horizontal line? No. It is a line with a slope. It has a slope of 2. Now, so I know it's going to go like this, but I need to know how high it goes, because that's going to determine how tall my triangle is. Okay? How do I find that point? Take the 4, substitute it in there. 2 times 4 is 8. So this line goes, and I'm going to go ahead and stop at 4, 8. You always come down to the x-axis, never to the y-axis. That does get confusing. In this specific problem, it doesn't matter if you go to the x or the y, you're going to get the same answer. But you always need to go to the x. One side of the geometric shape will always be the x-axis. So here's my triangle. The area will be 1/2. Switching colors. The base is 4. The height is 8. So 1/2 of 4 times 8. Half of 4 is 2 times 8 is 16 square units. Okay? Now with calculus. Recopy the problem. 0 to 4, 2x dx equals. Integral from 0 to 4 of 2x dx equals. Now, remember the next step is you write down the antiderivative of this function. What has a derivative of 2x? X squared. Remember, we're going to leave the c off. Remember that the dx comes off as soon as you're done there. Draw the back bracket, bring the two numbers over, the 0 and the 4. Now remember the formula said f of b minus f of a, so we always plug the top number in first. So the answer will be 4 squared minus 0 squared, which is the same answer we got with the geometry, 16. I believe I have one more example to do, and then I will be finished. Final example. The integral from -1 to 2 of 6 minus 2x dx. A little bit more involved. Quadrant 1. Second of all, there are two terms in here that I'm going to have to take the antiderivative of. So, geometry, and a little more room for the calculus. All right. Because I go into the negatives for my x's, I need to draw two quadrants. So here's -1, here's +2. Here's the easy way to do this. Take -1, substitute it into the function. What is its y value? It happens to be 8. So I'm going all the way up to 8 over here. -1, 8. I know this is linear. So I'm just going to be drawing a straight line between where this side stops and where the other side stops. When you substitute 2 in here, 2 times 2 is 4, 6 minus 4 is 2. So this point is at 2, 2. The line is going to go this way, and that is the proper slope because the slope is negative. It continues down here and up there. You really don't have to draw that part if you don't want to, but you do need to draw straight down to -1, straight down to 2. Here is my trapezoid. Kind of backwards, but it's trapezoid. So, area of a trapezoid is 1/2 the base times the sum of the heights. So we're going to have to squeeze this in here. Move it up just a little bit so everybody can see. So it's 1/2. The base is the distance between these two values, which is 3. The height of this side is 8. The height of this side is 2. So we're going to substitute in 8 plus 2. I'd rather not do half of 3, so I'm going to multiply 3 times 10 first, which is 30. And half of 30 is 15 square units. There's my geometry answer. All right, now for the calculus. So we're going to do the integral from -1 to 2 of 6 minus 2x dx equals. Remember, we're doing antiderivative first. The antiderivative of a 6 is 6x minus the antiderivative of 2x is x squared. Then you draw the back bracket, -1, +2. -1 on the bottom, 2 on top. All right, here's the tricky part. If you have two terms here, you have to substitute the 2 into both of them, minus -1 substituted into both of them. So I need to move over here. I need to draw parentheses. So it's going to be 6 times 2 minus 2 squared, parentheses. So I put the 2 in for both the x's. Minus, parentheses, 6 times -1 plus -1. Oops, messed up. -1 squared is minus. Let me fix that real quick. It's minus. There we go. All right. So this will be 12 minus 4, which simplifies to 8, minus, do the other parentheses, totally clean it up. 6 times -1 is -6, minus -1 squared. You square first, which is 1. So minus -6 minus 1 is -7. 8 minus -7 plus a positive, 15 square units. So that is how these problems are done. The sub will now hand out the worksheet if they haven't done so already. You are assigned to do problems 1 through 11 on this worksheet. We will spend some more time on this on Tuesday, but we're going to be going on to new material, so it's very important that you understand this procedure before we move on to the new material on Tuesday.